So let's use Excel solver to figure out the amount of ingredient X and ingredient Y that will give us the minimum cost as well as meet all the minimum and maximum requirements. Again, a recap of what's the minimum and maximum requirements from our question. So everything is given here. The cost per kg for ingredient X and Y, the protein per kg for ingredient X and Y, and the fiber per kg for ingredient X and Y, all are given here. So the minimum protein requirement of the drink is that it should be greater or equal to 300 units. For the minimum fiber, it should be greater or equal to 200 units. For maximum ingredient X in the drink, it should be less than or equal to 30 kg. For maximum ingredient Y in the drink, it should be less than or equal to 40 kg. So all the requirements are given here. Now let's see the blue cells. So total protein, how is it calculated? It's the amount in kg for ingredient X times the protein per kg for ingredient X plus the amount in kg for ingredient Y times the protein per kg of ingredient Y. That will give us the total protein. Similarly, for total fiber, just click on the formula and it will highlight the cells. Again, the respective amount for ingredient X and Y are multiplied by their fiber per kg to get the total fiber in the drink. And the total cost is cost per kg for ingredient X times the amount in kg for ingredient X, and similarly the cost per kg of ingredient Y times the amount in kg for ingredient Y, both are added to get the total cost. So what is our objective? Our objective is to meet these requirements as well as make the cost minimum. So how to do that? First go to data and then go to solver. If you don't see solver here, the way you can bring solver here is that go to file, go to options, and then add-ins. For Excel add-ins, go and then check for solver add-in, press OK. So how to solve it in Excel? Go to solver and then set objective is cell C17 where the total cost formula is given. We want to make the cost minimum. So select the minimum option by changing variables. So we want to find the optimal mixture of ingredient X and Y. So to find that, we need to select it as the changing variables. Subject to constraint. What are the different constraints? Ingredient X cannot be negative because in physical real world, nothing can be negative. So that's one of the constraints. Ingredient X should be greater or equal to 0 because it doesn't make sense that we have negative ingredient X. The next one is ingredient Y greater or equal to 0. Minimum protein requirement is 300 units and the total protein formula is given here. So select this cell and should be greater or equal to 300. So select cell C9 where the 300 is given. Add. Minimum fiber requirement is 200 units. So the total fiber formula is given here and then total fiber should be greater or equal to 200, which is cell C10. Are there any other constraints? Yes. So the maximum ingredient X should be 30 kg, means you cannot have 31 or 32 kg of 3 kg of ingredient X. Or you cannot have more than 40 kg of ingredient Y, means you cannot have 41, 42, or 43 kg of ingredient Y. So those are the constants you need to add to. That's how the solver works. So again, for maximum ingredient X means this one cannot be more than 30. So it should be less than or equal to 30. Add. Ingredient Y should be less than or equal to 40. So I think we are done with all the constraints here. So all the constraints are here and we should change the variables D3 and D4. So what is the solver going to do in the background is going to try different combinations of ingredient X and Y, which meets all the requirements and set the cost to minimum. So select a solving method. The solving method should be simplex LP. Why is it LP? Because it's the total cost. It's a linear formula. It is ingredient X cost per kg times the total kg of ingredient X plus the cost per kg of ingredient Y times the total kg of ingredient Y. So it's a linear formula. It's not really a quadratic or a cubic equation. It's a linear equation. So that's why do not select GRG nonlinear evolutionary. Select this one, simplex LP, and then solve. So these are the results we got. So for 23.33 kg of ingredient X and 8.33 kg of ingredient Y, the mixture or the drink is going to meet all the constraints or all the requirements, and at the same time, the cost will be minimum, which is $135. So keep the solver solution, press OK. So let's interpret the results. The optimal solution for the energy drink problem is as follows. Ingredient X 23.33 kg, ingredient Y 8.33 kg. The minimum total cost of production is $135. By using 23.33 kg of ingredient X and 8.33 kg of ingredient Y, the factory meets the nutritional requirements, at least 300 units of protein and 200 units of fiber. This combination minimizes the production cost while staying within the limits on ingredient quantities. Scenario recap. You worked on a problem to minimize the cost of creating an energy drink by blending two ingredients, ingredient X and ingredient Y. You had to meet nutritional goals, that is protein and fiber, while staying within ingredient limits. You used simplex LP method because your problem was linear. Both the objective, cost minimization, and the constraints, nutritional limits, were straight lines. What is the step-by-step method? Set the objective to minimize cost. Selected ingredient X and ingredient Y as the decision variables. Applied constraints, protein, fiber, and maximum ingredient limits. Solver found the optimal solution to minimize cost while meeting all the requirements. Takeaway: Solver helps you optimize complex decisions with ease. Whether minimizing costs or maximizing profits, Solver is a powerful tool to find the best solution.